Okay, welcome back. So in this one here, it wants you to determine the vertex of the quadratic defined by y equals x squared plus 5x plus 6. There's a couple ways of going about this. Now, again, it doesn't specify what method to use, so in theory you could use factoring. If you can see if there's factors, this one in particular does. From there, find the zeros, the axis symmetry, and the vertex. You could use partial factoring. And again, from there, find two symmetric points, find the axis symmetry, find the vertex from there. Or you could use completing the square. Now, just for practice, I'm going to use completing the square for this one, but any other method would work. And if I don't specify in a test, you can feel free to use whatever method you like as well. But let's, again, for the practice, try and use completing the square on this one. So I have x squared plus 5x plus 6. The a value is 1 here, so it's not as complicated as the last one we looked at. So just like before, we're going to ignore the c value, just work with the x squared plus 5x. So here's my array over here. Okay, so I have x squared. Now, how do I split 5x in half in order to get the exact same value here and here? Well, 5 divided by 2 is 2.5, but we would like to use fractions. They tend to be a bit more precise. So 5 divided by 2 would actually be 5 over 2. So I'm going to put plus 5 over 2x here, and plus 5 over 2x here. Okay, which means I'm going to have x plus 5 over 2 times x plus 5 over 2 on the outside. Okay, so what's going to have to go down here in the bottom right part of the array? Well, 5 over 2 times 5 over 2 is 25 over 4. 5 times 5 over 2 times 2. So that means I'm going to have to, over here, when I take x squared plus 5x, add 25 over 4 to make it a perfect square. But again, to compensate, to balance, I have to subtract 25 over 4. Okay, that plus 6 was part of our original equation, is just along for the ride. Okay, and this is one of those times where it's really, really helpful to have the array drawn out. I mean, if I had given you this here to factor, when we did the factoring, you'd been very, very upset. You know, there's fractions in there, how am I supposed to figure that out? But when you have this array drawn out, the factoring answer is staring at you in the face. X squared plus 5x plus 25 over 4 is x plus 5 over 2 all squared. You have that in the array. So what's underlined here in purple automatically becomes x plus 5 halves all squared. Okay, and then what's left over? Well, I just need to work with these fractions here. So I have negative 25 quarters plus 6, which works out to being negative 1 over 4. Okay, so there's my vertex form right there. I forgot my y equals, but there's my vertex form right here. And from there I can state my vertex. My vertex, my h value is going to be negative 5 over 2. And my k value is going to be negative 1 over 4. So that should be my vertex. Okay. And again, there might be a few other ways of going about it, using partial factoring or factoring, but just for good practice here, this would be how you do it using completing the square. If you tried another method, you didn't get the same answer, come see me. We can check through your math and see where we made a mistake. Because no matter what method you use, you should wind up with the exact same value for the vertex and for vertex form if you were asked for it. Okay, so let's take a look at a word problem here. So the height after t seconds of a foul ball is modeled according to h equals negative 5t squared plus 30t plus 2. So it's asked us to find the maximum height of the ball. Now, maximum height is the optimal value. So that's the y value of vertex, in this case the h value of vertex. So we need to find the optimal value. Now, unlike the last one where we had options, including factoring, partial factoring, and completing the square, this one does not factor, so that gets rid of that option. So you have to use either partial factoring or completing the square in order to find the vertex for this. Again, for practice, I'm going to use completing the square. Okay, we did partial factoring last lesson. Again, feel free to use that method, but again, try all the different methods just so you get used to all of them and see which one you like best. And try to do completing the square for this one. So to complete the square, you'll notice here that my a value is not 1. So just like before, I'm going to factor the a value out of my first two terms. So I'm going to wind up with h equals negative 5, and what's left over is going to be t squared. 30 divided by negative 5 is minus 6, so I have t squared minus 6t. And that plus 2 just gets hanging around. Okay, so from here I want you guys to try and finish completing the square on your own. When you get it in vertex form, try and find the maximum height, and then we can then check to see if your answer is right. Okay, so you can take a look at the vertex form from here. So when I take out the negative 5 and I have t squared minus 6t, I complete the square on that. So I found I had to add 9 to create a perfect square. So I added 9, subtracted 9 from the equation. Now remember here, because we have an a value that's not 1, make sure you keep that plus 9 and minus 9 inside the bracket that's multiplied by negative 5. So in the next step, when I don't need the negative 9 to make the perfect square and I kick it out of the bracket, I have to remember to multiply it by that a value, that negative 5. Okay. So t squared minus 6t plus 9 factors in t minus 3 times t minus 3. Tiny little mistake here, t minus 3 times t minus 3. And which is t minus 3 all squared. Out here I have negative 9 times negative 5, which is 45, plus 2 is 47. So the maximum height of the ball, well, if you think about my vertex being at 3 seconds and 47 meters, the maximum height right here is going to be 47 meters. Okay, so that answers part A. Part B asks us for the total time the ball is in the air. So again, with word problems, the tricky part is trying to figure out, okay, well, what part of the problem am I being asked to find? So if you think about it, we have a parabola opening down. If we want to figure out what the total time the ball is in the air, we've got to find out when the ball is on the ground. So when is the ball on the ground? That's going to be at the zeros. Okay, so normally to find our zeros, we have to put it into factored form. But if you try with the original question there, the negative 5t squared plus 30t plus 2, you can try all day. You're not going to find something that factors. This one does not factor. Okay, and you can see from the answer here, the nice ugly answer 6.07, that's not going to factor nicely either. So what we're going to do is, now that we have it in vertex form, we're going to use that vertex form to help us find it. Because we know if we're trying to find the zeros, so for part B, if we're trying to find the zeros, then the height of the ball is going to be equal to 0. So if the height of the ball is equal to 0, we can sub that into the equation. And the nice thing about vertex form is that the independent variable, which in this case is t, usually it's x, but in this case is t, the independent variable only shows up once. So if the variable only shows up once, we should in theory be able to solve it. So to solve this here, I'm going to subtract 47 from both sides of the equation. So I'm going to have negative 47 equals negative 5 times t minus 3. And we did a few like this a couple lessons ago, so we might be a little bit rusty on it. But again, we have done this process before. So divide both sides by negative 5. That's going to be positive 47 over 5 equals t minus 3 squared. When I take the square root of both sides now, because that's something I can do now to get just t minus 3 on this side, I have to have plus or minus the square root of 47 over 5. Okay, so then on my next step I'm going to add 3, so I have plus or minus the square root of 47 over 5 plus 3. Okay, so that tells me two things. I have two zeros here, so 2 times in theory when the ball is at 0. So one of them is going to be when time is equal to square root of 47 over 5 plus 3. Okay, and I'll let you find the decimal equivalent on your calculator. Or when time equals the negative square root of 47 over 5 plus 3. Okay, so again, plug those in your calculator, see what you get, and let's see if these answers make sense. Okay, so when you plug these in your calculator, you should get these two decimal equivalents. Now, if you're looking at where these answers are valid, it does not make sense to have a negative time. Time cannot be negative. So this one right here, we're going to call inadmissible. It's not a valid solution in this case. So it means the only possible answer that we have here is that it hits the ground for 6.07 seconds. So that's how long the ball is in the air for, 6.07 seconds. Okay, let's take a look at the next one here. So here we want to find the transformations applied to y equals x squared to get our graph of negative 4x squared minus 40x minus 87. Then it wants us to make a graph. Now, one thing you remember when we started this unit, if we want to find the transformations, we need which form? You guessed it, vertex form. So I'm going to have you guys put this into vertex form, and from there, try and find the transformations. I want you guys to work through this one on your own and see what you can come up with, and push play and you're ready to go through the answer. Okay, so take a minute here and check your answer. So I use completing the square, again just for the practice because it's new for today. Factor out the negative 4 from the first two terms, was left with x squared plus 10x. I figured I had to add 25 and subtract 25 to make it a perfect square. Again, the general process we always see is that this is what we need for a perfect square. The minus 25 was just extra, so I booted out of the bracket there, which means I multiplied by the a value of negative 4. So x squared plus 10x plus 25 factored into x plus 5 all squared. When I simplify what's outside the bracket, I get positive 13. So that gives me my equation in vertex form. So I could get the transformations from there. If it helps to see the transformations a little bit easier, you can create the mapping rule. So the mapping rule will be x minus 5 and negative 4y plus 13. And from there I can get my transformations. So the negative 4, the a value tells me I'm reflected in the x-axis. I have a vertical stretch of a factor of 4. And the minus 5 and plus 13 tells me I move left 5 and up 13. Now if I wanted to make a graph, when we did graphs, accurate graphs, since we're transforming points from y equals x squared, we take points from y equals x squared like 0, 0, 1, 1, 2, 4, and so on and so forth, and use the mapping rule to see where these points wind up. So for example, if I put 0, 0 in here, 0 minus 5 gives me negative 5. Negative 4 times 0 plus 13 gives me 13. So I have a point negative 5, 13, which I should be able to put on my graph here. So negative 5, 13 would be somewhere up here. Okay, it appears that the current graph that's on here is not accurate. So 1, 1, I could do the exact same thing. 1 minus 5 is negative 4. Negative 4 times 1 is negative 4, plus 13 is 9. So negative 4, 9 is a point. Okay, 2, 4, keep going. 2 minus 5 is negative 3. Negative 4 times 4 is negative 16, plus 13 is negative 3. So negative 3 is a point right there. Sorry, negative 3 is a point, which is down there. So that would give me half my parabola right here. I can use symmetry to get the other half, or I could use more points from y equals x squared, and I could generate my sketch or my graph from there. Okay, so that would be the graph of this guy, y equals negative 4x squared minus 40x minus 87, using a mapping rule. Okay, last one. We're going to put together everything from the unit here. You may need to look some things up from earlier lessons if you forgot. But here I have an equation in standard form. We have 3 different ways of finding the axis symmetry. I'd like you to use all 3 to find the axis symmetry. You should get the same answer, obviously, each way. And then compare which method you prefer the best. So again, take some time to go through this. Again, try all 3 methods: completing the square, which we learned today, factoring from a couple units ago, and partial factoring from earlier on this unit. See what you can get for the axis symmetry in each case, and think out which one you think is fastest. Okay, and push play and ready to go through them together. Okay, let's quickly summarize here. So for completing the square, you can see my work here. So I factored out the 3, the a value from just the first 2 terms, got x squared minus 4x. Completed the square there, and I wound up with, in vertex form, 3 bracket x minus 2 all squared minus 48. So from there I could read off my axis symmetry as being x equals 2. If I was going to factor, what I look for first is the greatest common factor for all terms, which in this case is 3. If I factor out the 3, I have x squared minus 4x minus 12 left over. That's a simple trinomial from a couple units ago. So you wind up, when you try that in the array, you get x minus 6 times x plus 2. So I get my 2 zeros at 6 and negative 2. Add them together, divided by 2 to find the axis symmetry being x equals 2. And last but not least, in partial factoring. In partial factoring, you common factor the first 2 terms fully. So between 3x squared and minus 12x, I took out 3x. I was left with x minus 4. And while it doesn't give me the zeros, it gives me the points 0, negative 36, and 4, negative 36. And since these 2 points have the same y value, I can use those x values of 0 and 4 to get my axis symmetry at x equals 2. So 3 ways of going about finding the axis symmetry, all perfectly valid. If you might think, well, at first glance you probably thought that partial factoring was faster, and I would tend to agree. If you're just looking for the axis symmetry, partial factoring probably is faster. Factoring is not too bad, provided you can factor it, although not everything does factor. Completing the square, once you do a lot of them, tends to go relatively quickly, but it's a bit of a process here. And again, I'm just trying to show you a lot of different tools to go from standard form to vertex form. I'd like you to know all of them. I might force you to use all of them at least once, but in general, you can choose whatever method you like to go from standard form to vertex form. In general, I would say if you just find the axis symmetry, partially factor form is the way to go. If you're trying to find the full vertex form like we did over here, partial factor form is still a bit more work left to do. You have to sub that x value into the equation, solve for the optimal value, and create vertex form from there. In that respect, it's probably about the same to the same amount of time to go from standard form to vertex form using completing the square or partial factoring. But again, it really just becomes a matter of preference at that point. So a lot of different approaches there. They all tend to work, so it's just a matter of what you prefer. Okay, so that's it for this unit. A couple of, obviously some practice there in the homework for completing the square, and then we'll start getting you ready for a unit test. Okay, that's it. That's all. Cheers.